All right, one last thing on this topic, and this is going to be slightly different, and this is drawing Lewis diagrams of covalent compounds. So covalent compounds are a little bit different in their Lewis structure formation than ionic compounds because since I don't have the transfer of electrons, I can actually form many different types of Lewis structures, many different types of molecules using the exact same elements. So for example, carbon monoxide or carbon dioxide, or all the different things that I can make using just carbon and hydrogen. So when I'm given a covalent compound and I'm asked to show the Lewis structure, I'm going to have to be given either the name or the chemical formula. So here I'm given CH4. And the first thing I need to do in order to draw the Lewis structure here is to determine how many valence electrons I'm working with. So the way that I like to do this is to make a little chart. So I have carbon. That is not. Carbon, which has 4 valence electrons. And I have hydrogen, which each has 1 valence electron, but I have 1 carbon, and I have 4 hydrogens, which means I have to multiply these by 4, which means I have a total of 8 valence electrons that I'm working with. Next, I'm going to determine the central atom. So the central atom is going to be the one that's in the center, as the name implies, and in general, it's going to be the one that you have less of. So here, I'm going to pick carbon to be my central atom. Next, I'm going to single bond my other element to the central atom. So I'm going to have one single bond to one hydrogen, one single bond to another hydrogen, one single bond to another hydrogen, and one single bond to my next hydrogen. Remember, each of those single bonds is actually 2 valence electrons because I'm sharing the electrons. So each line there represents 2 shared valence electrons. Next, I'm going to figure out how many of my valence electrons that I had are being occupied in those single bonds. So here I have 1, 2, 3, 4 single bonds. 4 times 2 is 8 bonding electrons, so I'm going to subtract out my bonding electrons. So minus 8 bonding electrons, which gives me 0 left over. If I had more valence electrons remaining, I would go back and look and maybe put in some double bonds, or maybe make sure that all of my valence electrons are accounted for. All right, let's look at another example. Here I have OCl2. So same thing, I'm going to start by figuring out how many total valence electrons I have. So oxygen has 6 valence electrons. Chlorine has 7. I have 1 oxygen, so I'm good there, but I have 2 chlorine, so that's 7 times 2. So that's 14 right here. Oops, no, go away. 14 here and 6 here, so I'm pretty bad at math, but I think that's 20 total. 14 plus 6 is 20 total valence electrons. Just like before, I'm going to find my central atom. In this case, it's oxygen. I'm going to put my single bonds to my other elements. So chlorine, chlorine. And just like before, I'm going to count how many of my valence electrons I've used for those bonds. So I have 2 bonds. Each bond is worth 2 valence electrons, so I'm going to subtract my 8 valence electrons. 4 valence electrons, which gives me 16 remaining valence electrons. All right, those are bonding electrons. So I'm taking my total valence electrons, I'm subtracting out my bonding electrons, and that's going to give me my leftover valence electrons. So now I have all these leftover valence electrons, but I can tell that no one here has a complete octet, right? So chlorine effectively has 2 electrons, oxygen effectively has 4, and chlorine effectively has 2. So I'm going to go back and distribute the electrons to try to give each of the atoms an octet. So I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So now I've used up all of my 16 remaining valence electrons. And now, I'm going to double check that my math worked out correctly. So here, chlorine has 6 valence electrons and 2 bonding electrons, which means he has an octet, so he's good. Oxygen has 1, 2, 3, 4 valence electrons and 2 different sets of bonds. So 4 plus 4 is 8. So he has an octet. Chlorine has 6 valence electrons plus the 2 that are participating in bonding. So he has an octet. So everyone is happy, and this is my